Welcome, ladies and gentlemen, to 1.3, which is entitled Dimensional Analysis and the Factor Label Method. If you came through chemistry, you've probably done the factor label method before, but we're going to be talking about it today. It's one of the most crucial pieces that you're going to have to know how to do in all of physics. People who miss this here struggle with it the entire year, and you will use this every single chapter from now until the end of the year. So I really want you to pay close attention to this lecture, and I really want you to work hard to understand this. Today there's actually 4 different cases that I can think of when we talk about the factor label method. Case number 1, you're going from a base to a prefix and a prefix to a base. Case number 2, going from a prefix to a prefix. Case number 3, using fractions. And case number 4, using powers. So basically what dimensional analysis factor label method is, it's a fancy way for converting between units. It's a fancy way to convert between units. I do this as my little shorthand for between. Let me give you the first some examples, just so you kind of see how this works. You have to know your prefixes. You cannot do this without knowing the prefixes, so you're going to have to memorize those prefixes that we learned in 1.2. So first of all, my first example, going from a base. Now a base means, what I mean by that is something with no prefix. So grams, this has no prefix. Meters, that has no prefix. Amps, that has no prefix. Meters has no prefix. Now the thing is, it doesn't matter if you understand what that means or not. You don't have to know that this means amps. What's important is the prefix. As long as you know that that's the Greek letter mu, and that means micro, which means million, sounds like million, we're going to do this. So here we go. The first step is to start out with what you're given. So I'm given 500 grams. Step 2 is to make a fraction bar. Now what I'm going to do is I'm going to put grams on the bottom, and I'm going to put megagrams on the top. And then what I'm going to do is put some numbers in here. They're very specific numbers, because what I'm going to do, this whole quantity equals 1. Equals the number 1. And let me give you an idea. 1 megagram is equal to 1,000,000 grams. So anything divided by itself is 1. So when I multiply this by itself, it's not changing anything. So when I multiply this, I take 500, multiply by everything on the top, divide by everything on the bottom. So I'm going to pull out my calculator and just show you how I would do this using my calculator here. I would take 500, multiply by everything on the top, so it's just 1, and then I'm going to divide by everything on the bottom, 1,000,000. I'm going to do this, 10 to the 6th. I get 5e negative 4, and your calculator, that's short for 5 times 10 to the negative 4th, or 0.1234. I prefer it like this. It's just less ink. If you have to do more than 3 zeros, I do not want you to write all these zeros out. I want you to write it in what's called scientific notation. Let's try another one. I start with what I've given, 26 kilometers. The next thing I do is I draw my equivalency bar. I'm going to put kilometers on the bottom, and I'm going to put meters on the top. The units on the top cancel the units on the bottom. This is kind of an algebra trick that you learned back in algebra, that factors on the top, factors on the bottom, they can cancel as long as they're all multiplication in between there. So my trick for doing this is I always put a 1, whichever one's bigger. If meters is bigger, I'll put a 1 on the top. If kilometers is bigger, I'll take that 1 and I'll put it on the bottom. So you ask yourself, is kilometers bigger than miles? Meters? Yes, it is. Now, kilo, if you remember, is a prefix of 3, 10 to the third power. I'm always going to use positive exponents when I'm doing these problems. So you're never going to see me do a negative exponent here, even though you know that something means negative, and you'll see that in my next example, what I mean. So then 26 times 10 to the third is 26,000 meters. My next one, 0.00039 amps, and I'm going to change it into microamps. So I'll put an amp on the bottom so that those cancel. Top and the bottom have to cancel, and then I'll change it into microamps. Now here's where I'm talking about with the negative exponents. Remember I told you before I put a 1 on whatever one's bigger? Now the question is microamps bigger than amps? No. Micro is very, very tiny. It's a small fraction of, so I'm going to put a 1 down here. And then micro means 10 to the 6th. It means negative 6, but I'm always going to use positive exponents. There's literally 1 million microamps. This is true. There's 1 million microamps in 1 amp, so this is equals 1. So I multiply everything on the top, 0.00039, or I'm just going to move the decimal point 6. If you're not comfortable doing this in your head, I can do this in my head. I'm going to move this 6 decimal places. 1, 2, 3, 4, 5, 6. So this is going to equal 390 microamps. And again, it doesn't matter if you understand that the A stands for amps. What's important that you understand is that the prefixes. I'll just check it out here just to show you. $390. My last one. Sometimes you're going between two different units, like the metric system and the English system. So we'll start out with 5,000 meters. This is a cross-country race. And I'm going to change meters into miles. Now this one's kind of clever. I like this one. This one's a secret one. It's my bunny. It represents magic. And I don't know if you know why he smiles, but he smiles because he likes physics. Remember my trick talking to you about one of these is bigger, 1 mile, 1 meter. I don't know which one. You know that miles are bigger, but 1 mile equals how many meters? You might know this if you run track. How many meters are there in a mile? 1,600. Look at there. That one's kind of neat. So you multiply everything on the top, 5,000. Divide by everything on the bottom, 1,600. You get 3.125. That's where it's 3.1 miles. You all knew that if you ran cross country. Now, case number 2. What if we're going from one prefix to another prefix? What I'm going to do here is do an intermediate step. And let me show you how this works. 589 picofarads. Again, you don't have to know what the F means. It's not important. I'm going to change this into the base unit. And then I'm going to go from the base unit into what I'm trying to get to, microfarads. Farads are a unit of capacitance. It doesn't matter. Again, if you know what it means, it doesn't know. But here's the trick. The trick is we're going to do it twice. We're going to put a 1. Let's put a 1, whichever one's larger. Pico is very tiny, so we know that that's not the larger one. The larger one's up here. And pico means Pikachu is how old? 12 years old. No negative exponents. F. This is the larger one because micro is a very small. Micro sounds like million. 10 to the 6th. So you multiply by everything on the top. I look and see what cancels here. Picofarads cancels picofarads. Farads cancel farads, and I'm left with microfarads. So I multiply everything on the top, I divide everything on the bottom. Now if you're not comfortable, I can do this in my head because 10 to the 6th minus 10 to the 12th, these actually cancel, and I'm left with 6 on the denominator, so I'm going to subtract 6 decimals. Or if you're not comfortable, you can just outright do it. 589 times 10 to the 6th divided by 10 to the 12th, and you get 5.89 e negative 4. Or move this over 6, so 1, 2, 3, 4, 5, 6, so there's 3 zeros, the 5.89 times 10 to the negative 4th. My next one, a computer one, 0.007 terabytes to gigabytes. I'm going to take terabytes and change it first into bytes, and then I'll change bytes into gigabytes. So I put a 1 over what's larger. Now notice the 1 is not always on the top. In this case, terabytes is bigger because that's on the bottom. Tera means to the 12th, I think. Now I'm going to put bytes here. Gigabytes is larger, and giga means 10 to the 9th. So these cancel. These cancel. So I multiply by everything on the top. 10 to the 12th, divide by everything on the bottom. 10 to the 9th. I can subtract those. 12 minus 9 is 3. So I'm going to move this. I'm going to be multiplying by 1,000. 1, 2, 3. So this is going to equal 7 gigabytes. Or I can just use my calculator again. 0.007 times 10 to the 12th divided by 10 to the 9th. 7. The third case, fractions. Fractions we're going to treat just like we always did. The units on the top have to match up with the units on the bottom. So let me do this first one. I'm going to start with 55 miles per hour. See how I made that into a fraction? Next, what I'm going to do, I either have to change hours into seconds or miles into feet. You can do either one you want. Let's do miles first. Miles into feet. So in 1 mile, there's 5,280 feet. So there goes my miles. They are canceled. I'm going to do another step and change hours. Notice how the hours are on the top. The top has to match the bottom. Hours on the top, and I'm going to make seconds on the bottom. You might think in 1 hour there's actually 3,600 seconds. Or if you're not comfortable doing that, you could do another step. You could say 1 hour is equal to 60 minutes. And then you can go 1 minute equals 60 seconds. So then the hours cancel, and then the minutes cancel. I color code these just so you can see what they're canceling with. So you multiply by everything on the top, 55 times 5,280, and then we're going to divide it by 60, and then we're going to divide it by 60. So it's 81 feet per second. My next one, 65 meters per second into miles per hour. So here's going to be like a metric and conversion. So I'll do 65 meters per second. And what I'm going to do is I'm going to change meters into miles. And we all know that conversion. There's 1,600 meters in 1 mile. And then I'm going to change seconds into hours. So there's 3,600 seconds in 1 hour. So go back to the calculator. 65 meters per second. So I'm going to multiply by 3,600. And I'm going to divide by 1,600. And I get 146 miles per hour. Now the last case you're going to come up against is powers. Powers are a little bit trickier because I'll just show you this very first one. 1 cubic feet, change it into a cubic inch. And we all know that a cubic foot is something that's 1 foot by 1 foot, and it's 1 foot tall. So this is 1 foot by 1 foot. But you know that there's 12. You might think that, oh, this just is this 1 cubic feet into a cubic inch, that just equals 12. It's not the case. Because in every inch there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 inches. And then there's 12 this way. So there's literally 144 of these squares on the top. And it's actually 12 deep. So this one's really complicated. There's actually 12 times 12 times 12 cubic inches in a cubic foot. So that's how this actually works. These powers work like that. 1 cubic foot. There's 12. Oh, wait. That's not right. I'm going to change cubic feet into cubic inches. In 1 cubic foot, there's 12 times 12 times 12 cubic inches. So 12 times, I'll just go 12 to the third. Times 1 is going to be 1,728. (621 square millimeters in square centimeters). So 628 millimeters squared. And a fun fact is that there are 10 millimeters in 1 centimeter. That's something I'm going to have to know. That I'll change millimeters squared into centimeters squared. So this one's larger, centimeters, and there are 10 times 10 millimeters squared in a centimeter. So this is going to be 628 divided by 100, which is going to be 6.28 square centimeters. Cubic inches to cubic centimeters. My motorcycle's 88 cubic inches. How many cc's is that? cc stands for cubic centimeters. I've got 88 cubic inches, and I'm going to change cubic inches into cubic centimeters. Now, in 1 inch, there's 2.54 centimeters. So I got to take 2.54 times 2.54 times 2.54 to do this one. So 2.54 to the third power, multiply by 88. It's 1,400 cubic centimeters. So my motorcycle's right around 1,400 cubic centimeters, cc's. So these power ones are a little bit tricky. They take a little bit getting used to, but there's a pattern amongst all of them. They're all the same in the fact that you have to make the units on the top cancel out with the units on the bottom.